Okay, I guess we're going. Hi, everybody. My name is Scott. I'm founder and engineer of a company called Chickadee Tech. And what I like to do is basically stream when I'm working. Not all the time. I work more than I stream. Um, but in particular, this project that I'm working on right now is the M0 Arduino compatible control board. And my goal with this board was to document absolutely all the work that I did on it. So um, last time we circled back and did the final silkscreen and stuff for the board before sending it off to OSH Park, and I got really lucky. They have a super swift service, and my boards actually got bundled with somebody else's super swift run. So here's what the board looks like. That's the top side. It's hard to see that there's a ton of traces there, but there are. And the silkscreen looks decent. This is a mouse bite because it's aggregated into a larger panel. And then here's the reverse side too for completeness. So I got that, and I didn't expect it to come so quickly. And so I don't actually have the parts yet to put this on and see if it works. So I may have some of them, but I don't have them all. So what we're going to do today is previously we started the bill of materials in MacroFab thinking that I would have MacroFab do the first prototypes. But I was watching the Adafruit Maker to Market, and they talked about the ability of, like, if you start with a bare board from OSH Park, you can put parts of the circuit on and then test it before you do the whole thing. And so that's kind of what I'm going to do here is I want to put the power circuitry on first, like Lomora suggests, and then go from there. So I'm going to do it myself. It's also really a good process just to like think through the whole design as you're assembling it. So I'm going to do that. I'm not sure price-wise how different it is, but a lot of these parts I do have already. So what we're going to do today is we're going to do the bill of materials in a spreadsheet, and I'll show you what my setup looks like for that. Basically what I have is I have a big binder full of all these SMD parts when I was doing the first batch of everything. And so I've got, let me switch to the computer here. So ignore this. All right, this is what I've got right now is I've got a big long list of all of the different boards, well, all of the different parts that I have and how much I actually have. These numbers should be pretty close. A few of these, like the spacers and stuff, may be wrong. But you can see, like, oh, here's my diodes and the MOSFETs that I've got and all sorts of different things. So what I can do is then I can actually figure out what I need to purchase through some complicated spreadsheet voodoo. I can figure out how much I need to order. So to start with, all I'm going to do is we need to make a spreadsheet with the manufacturer part number. So what we'll do is we'll put parts that I've already got. I will just use the manufacturer part number from the part inventory. And then for new parts, I will add them in here and copy them. Add them into the part inventory and then copy them into the individual BOM. And that way I can use that thing to compute exactly how many of every part that I need to order. So the end goal is to catalog all the parts that we need for the M0 board, and then I'll order them from DigiKey or Mouser. The other tricky thing is that there are a couple other boards that I want to prototype. So the VTX board, the schematic's almost done, and the layout really shouldn't take that long. That's another board that I am kind of trying to do a bunch of video streams on. And then the last board that I'm working on is the autonomous navigation board, which will have a barometer and magnetometer along with a GPS plug. And that's for iNav support with Polystack, and potentially, well, probably, if people want it, ArduCopter and ArduPilot support as well. I don't know exactly what what boards and stuff those things need, but we'll see. Um, so yeah, that's what we're gonna do. The hat is because I haven't showered, and I haven't showered because I'm barbecuing today, so I'm like all smoke scented anyway. So I'm gonna wait till the barbecuing is done. I'm super excited about it. First time I've like smoked any meat on our barbecue, so that's gonna be really cool. So I may actually run off and check that too. I just want to check the temperature of the meat and then take it off the grill when it's good. So yeah, so boards came. We need to order parts, and let me show you how I do that. So this is the catalog of all the parts that are all on all the boards, and this is like the central location. So this applies to all of the different Polystack boards. The advantage of doing this is that you can share parts amongst different designs, which means that when you make them, you order more, and when you order more, the price is lower typically. So you can see here that I've got resistors that I've just designated for different values, and they also have corresponding MacroFab house part identifiers as well. For the things that have MacroFab house parts, I tend to just look at the data sheet for what they've got and then use that part, although they reserve the right to use a different one, a different equivalent one. So yeah, so this is the central repository and inventory of all the parts that I have here for prototyping. It doesn't cover inventory for production. There's basically everything that I've purchased for research and development I've written off as an expense on taxes, so I can't sell them. So it's good to keep them separate, which is fine. Okay, so the way that it works is that I have this base expansion BOM, and it does a number of things for me. It imports basically A through H and J through L, all from that master part inventory doc. And it's doing, well, I guess the symbol it doesn't, but all these NAs are because I haven't given permission to load from the master part inventory. So if I do this, and now I say I want to import 300 and not 100. So this is just a straight up copy of the columns in here. So if I were to if I add another part at the bottom here, and go back here, it shows up. A little slow, but it shows up. So for the parts that I've never used before, we'll add them to the part inventory, and then they'll automatically end up here. And then once they're in here, all of this data gets pulled in from there, based on this column here of manufacturer ID. So we're going to rename this M0 BOM. And if you've looked at the open source repositories for everything, the GitHub, it's got just a CSV version of this file that was generated. So you'll also have the like units in stock, which is my stock. Okay. Cat's going crazy for a fly. So I'm going to do a little bit of hybrid. So here's the board. And I also want to open the schematic. So the way that I usually do it is I will open the schematic, and then in the view where you match up parts or schematic parts to footprints, you can basically see everything, which is, yeah, you can see it's a list of everything on the board. So basically what I do is I will create entries in the BOM for everything in this view here. So port in we don't have, and or. So this is mainly for mainly for the mods and not the control boards, so that's why I'm able to delete a bunch of this stuff. So if there's 10Ks here, so I'm just gonna say R6, R7. I'm looking right here. There's two 10Ks here. My laundry's done. And then for capacitors, we don't even need to count. We need to do C2, C3, C5, 7, 8, 9, C7, C8, and C9. And the cool thing about this script is that it automatically computes based on the symbols, how many units you have per build, which is very nice. And then let's see here. What order do I want to do this in? Port out. I'm gonna do actually, nobody's watching. I'm gonna go switch my laundry. I'll be right back. Hi, Vin. Okay, sorry about that. You know, I get like phone calls and stuff while I live stream. Okay, so I was just gonna start at the bottom. U1, U3. U3 we definitely have. It's the regulator that we use. So all I'm copying is the manufacturer part number. And now, once I paste that in there, it finds the right thing. But I don't think that we have the SAM chip in here. SAM Tech. SAM D10. So we can also look here where I think I selected everything already to get the full part number. Bill of materials. SAMD. DigiKey. DigiKey. We want cut to, we want in stock. Narrow it down for us. Alright. Actually, can we get them tray? Which one's cheaper? Tray is cheaper. It's a whole lot more on cut tape though. We'll just go with cut tape. So to add that to the part inventory, we put the full one here. Stop search. 21J. 0. Unit price. I tend to put just the singles unit price because we're prototyping. It's kind of interesting to get a rough estimate. Passport, no data sheet. And I'm going to ignore the rest of that. So take this again. Do that. Not percentage. So that looks good. So one other thing to check is whether it's a house part. I know the Sandy 21 is not going to be a house part though. Okay. Basically, I'm picking out all of the unique stuff. Let's do the switch. Going bottom to top. Switch top. Power switch. Obviously, I don't have a great system for finding things in this list. So, side switch. Down she goes. And loss. Okie dokie. So let's do all the 1Ks. R1, R2, R3, R4, R12. And they're all next to each other. So one here. 1K, 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 1K. And it's not showing up because I haven't copied it down. So let's just... Come on. Oh, she's behind me. Monkey. This is Vin. She loves laps. And she's soft because I brushed her earlier. Isn't that right, kitty? Alright, let's do 2K. And I don't actually have 2K in here. It's the first time I've used 2K, so I'm going to insert one below. And I'm going to do MacroFab house part. See if they have a 2K. I don't know what the 2K is used for. We do have it. I use 0603s for everything. There. And I'm going to buy the same series from DigiKey, so I'm going to take a stab in the dark and say, figure out what the number is. Okay. Look at that. Right on the dot. Aren't you impressed, Ben? Your dad's so good at this. That's a giant picture of a very tiny part. This resistor, I think, is actually better than the house part. But that's okay. I'm more interested in having the same series. Okay. And I'll probably buy 100 of them. So 057. And I don't actually care about data sheet. Okay. And let's see. R8 and R11. So I've done 1K, I've done 10K. 470, I have not. R10. And then there's a 330 in there also. I think that's all the resistors. So R10 is 100K, which we do have. R9 is a 470, which we should also have. 330 we don't. So let's do the same thing. Park. 30. Copy this. Change this. Price 0044. Okay, so we got scoot in then, scoot in. So now I'm just gonna do like a check that I got all the resistors. So I'm just gonna go R1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And there's 12 here, so we're good. We already got the 2 resistors. Polystack connector. We did it as a 3. And I don't know if it's actually supposed to be a 3. Let's just make it 3. So let's actually, we need to update this 12 to 2, which is quite short. And then these are all just pads. We don't need to worry about that. This we do need to worry about. So P5 is going to be 20-pin header, and P3 is going to be USB. Pin headers I've got measurement point define. L1, D3 and D5 are red. D4 is the power or. D2, D1, yellow and green. Okay, so let's do those. D5 is the 20-pin header. D3 is USB. And again, I picked the USB based on the house part that MacroFab carries. The inductor, I think I added this ferrite bead inductor. That's the one I want. And we want diodes. This is the power or diode 4. And the 2 red. One for power, one for activity. D2 is yellow. Alright, making progress. So we're up into our capacitors. We've already done our 0.1s. So we're going to need, let's see what we just did. So 2.2 is C15. And then C, now we'll do our 1s, so C6. C12 and C. Oh, just those two. And then, so those are 1s. Let's do our 10s. So C1, C4, and C. Plug that in. Wow. And then 15 is 2.2 microfarads. So, 6 and 12 are 1. That one's fancier than I actually need. So that's our bomb, I think. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 we skip, 11, 12, 15. We've got all our diodes. We got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We've got our ferrite bead. We've got our regulator. Oh no, that's a measuring point. USB. We've got our iris header. We've got our port out. We've got our MOSFETs. We've got our resistors. We checked our resistors. We have 1, 2, 3, 4, 12. Our 8, our 11. Switch. So that looks good, and this can give you an idea of just how much I'm reusing. So units in stock are things that I have from previous prototype boards. You can see that I'm missing the SAN-D, the 2K resistor, the 330K. So four things is all I'm missing, assuming everything is correct on here. I think I've been pretty good about it. I may double check connectors just to be safe. Yeah, that's the inventory. One thing you can do is now you can sum this up. If you wanted to get a rough estimate of part cost. H2, H23. So rough part cost is $13. And that's in singles, essentially. Resistors are not in singles, but resistors are like way cheaper if you buy 100 of them. So yeah, so that gives you a rough idea of our part cost. The boards from OSH Park were like $3 a piece. So this is really hopefully going to come in pretty inexpensive. There's, of course, when it gets manufactured, there's labor costs too, but those I think are a couple. On the first production one, they were just a couple dollars. So this board will be a great way to get into Polystack. Trying to think if there's anything else. Let's just glance over this and see. So this is interesting. Their part cost here is $15. But they aren't automatically giving discounts for buying a bunch of stuff. Like when I just chose to buy 100 resistors because it was actually cheaper, they don't. MacroFab doesn't actually do that. So that's why it's 5 cents when I potentially said it was cheaper. The LEDs might be cheaper too. These are house parts, so that they cost nothing to place. Yeah, like 25 cents or 5 cents a unit. It should be cheaper than that. They not have 1K? Oh, they. Let's see if we did 10, what would a unit price be? Yeah. And then $9 labor for 10 of them. There's a price break at 25 for labor. Yeah. Look at that. per unit. Oh, that includes PCB cost too. $23 a unit. Pretty reasonable. Okay, so that's one bomb. I've got to finish the other stuff. I just take a quick look at it. Where did I put all those capacitors? Here's one. Here's one. Huh. Hopefully I did that right. But I already got the board, so I might as well test it out. So you've been watching Chickadee Tech live stream on the up-and-coming N0 control board. It's going to be a big deal because it's Arduino compatible. And it uses all 6 Circoms, which is excellent. So if you're doing prototyping with Serial, this is going to be great. A lot of other prototyping platforms only allow you to do I2C, which is a shared bus, but this, you don't have to share the buses, which is really cool. Yeah, so I don't think I'll show the DigiKey order, but so hopefully the next video will be assembly of the prototype, and then we'll take a look at it and see how well it works. If you want more information, you can always email me, support@chickadee.tech. Place a comment below, like and subscribe. If you're interested in buying a Polystack with STM32, they're already available. They're available at chickadee.tech. And in the description, there's also a discount code for, I think, 10% off in order to get it in the hands of more people. So, again, thanks for watching, and I'll see you next time.